Today's lesson is bisectors of triangles. So we're going to be talking about the perpendicular bisector and the concurrent point called the circumcenter. All right, we're going to start out by reviewing the parts of a right triangle. They have two legs and the hypotenuse. So the two sides that form the 90-degree angle are called the legs, and the side across from the right angle is called the hypotenuse. Okay, and I use the Pythagorean Theorem when I'm solving for sides in a right triangle. So the formula of the Pythagorean Theorem is a squared plus b squared equals c squared. So it is leg squared plus my other leg squared equals the hypotenuse squared. And the hypotenuse is always the longest side. Okay, we're going to be working with right triangles for quite a bit, so I need to know how to use the Pythagorean theorem very easily. So looking at number 1, I am trying to find x here. Well, x is across from the right angle, so this would be my hypotenuse c. So I'm trying to solve for c. So I'm going to be substituting in, and it doesn't matter which one I call a or b for the legs. So I'm going to call this one a and this one b. So I'm going to substitute in. A squared is 18 squared plus b squared is 15 squared. And the hypotenuse is x squared. So I am trying to solve for x. So I know I want to take the square root of both sides. Whatever I do to one side, I have to do to the other side. So x, and rounding one digit, is going to be 23.4. So we're rounding to tenths, which is one digit here. All right, let's look at number 2. This time x is forming the right angle, so I am looking for either a or b. It doesn't matter whether I call it a or whether I call it b. So I'm going to say I'm looking for a in this example. It doesn't matter which leg I call that. So substituting in my equation, I get x squared. Here's my other leg b, and here's my hypotenuse c. So substituting in, I get 44 squared, and substituting in, I get 49 squared. So I'm going to solve for x. So the first thing I'm going to do is subtract 44 squared on both sides. So I get x squared equals 49 squared minus 44 squared. And I want the square root. So I'm going to take the square root of both sides. So I get x equals 21.6, rounding to tenths. Okay, can you do 3 and 4? Can you pause the video, work them out, and then come and check how you did? Okay, so if I'm looking at number 3, here is x. Here is this is a leg. So I'm looking for either a or b. So here I'm going to call this a. This is b, and across from the right angle is c. So substituting in, I get x squared plus 12 squared equals 20 squared. So I'm going to subtract 12 squared from both sides. And I get x squared equals 20 squared minus 12 squared. Okay, so next I'm going to take the square root of both sides, so I get x equals 16. How'd you do? Number 4, this is across from the right angle, so I know I'm solving for C. So it doesn't matter which one I call A or B, they're both legs. So substituting in, I get 7 squared plus 8 squared equals x squared. I need to take the square root of both sides. So I get x equals 10.6 squared. How'd you do? Okay, so that's just a warm-up. I need to be able to solve for sides of a right triangle, and I need to know if I want the leg or the hypotenuse. Okay, so for today's lesson, we're going to be talking about perpendicular bisectors. So the perpendicular bisector of the sides of a triangle intersect at a point called the circumcenter. So here is the circumcenter. So here is my perpendicular bisector. Here is my perpendicular bisector. And here is my perpendicular bisector. And point P is the circumcenter. So the circumcenter is always equidistant from the vertices of the triangle. From the vertices of the triangle. So each vertex, so that's telling me these are all equal distances right here, okay? So the perpendicular bisector already is on the midpoint of each side here. And then this hypotenuse in each of these triangles then is all equal. So the perpendicular bisectors on this triangle, these are the perpendicular bisectors. So they're PD, segment PD, segment PE, and segment PF. So these are the perpendicular bisectors. So the circumcenter is point P, and all my segments that are congruent so I'm going to start here on this side. So I have a perpendicular bisector. So bisector means I'm cutting in half. So a segment AD is congruent to segment DB. I know segment AF is congruent to segment FC. I know that segment BC is congruent to segment BE. It's congruent to segment EC. And then these segments are all congruent. So segment from the vertex to the circumcenter are all congruent. So segment AP is congruent to segment AB and congruent to segment AC. Okay, so when I use the word perpendicular bisector or circumcenter, I know all these segments are congruent. Okay, so if Z is the circumcenter of triangle TUV, find each missing measure. So I would start by putting in my congruent segments so I know what is congruent. So these are my perpendicular bisectors. So I know that these two segments are congruent because that's the midpoint. These two segments are congruent. These two segments are congruent. And then from the vertex, these segments are congruent. Okay, so if T to U, so T to U is the whole thing. So if I know segment X to U is 19, I know T to U is 19. So this is going to be 19 plus 19, which is 38. Okay, so V to Y. So here, what is V to Y? So V to Y, if I know the whole thing is 34, so I'm going to divide that in half. 34 by 2 is 17. See, U to Z, so U to Z. So this segment U or V to Z is 21, so U to Z is 21. So W to V, so where's W to V? So I want to know, I'm going to look at this triangle here. So if I need to redraw that so I can see that I have a right triangle, I'm trying to find, this is W to V right here. So I know this is my hypotenuse C. So these are my legs A and B. So I'm going to set this up as W to V squared plus 15 squared equals 21 squared. So I'm using the Pythagorean theorem here. So I'm going to subtract 15 squared from both sides. So I get W to V squared equals 21 squared minus 15 squared. And then I want to take the square root. So I get W to V equals 14.7. And T to V. T to V. So T to V is the whole thing. So we just calculated that this is 14.7, so this is 14.7. So this is going to be 14.7 plus 14.7, which is 29.4. Okay, so I have another one. I would work through this myself. So I'd pause the video and then check how did you do. And I would start by always putting in the markings so you know exactly what's congruent to each other. So these are the perpendicular bisectors. So I know these are the midpoints. So this is a midpoint. This is a midpoint. This is a midpoint. And then from each vertex to the circumcenter, these segments are congruent. So I would label all these first and then answer the questions. So G to D, so from G to D, so if the whole thing is 24, the midpoint is 12, so half and half are 12. So B to C, so from B to C, if this segment is 7, I know this segment is 7, so this is going to be 7 plus 7, which is 14. E to H. So E to H here. E to H here. So right now, I know that this is 11, so I know this is 11. So I think it might be easier to redraw so we can see what we're looking at. So the hypotenuse here is 11 because this is 11 on this one. Okay, and those are congruent, so this is 7. So I'm trying to find E to H right here. So 11 is my hypotenuse C. So I'm going to call these A and B. So I have EH squared plus 7 squared equals 11 squared. So I'm going to subtract 7 squared on both sides. So I get E to H squared equals 11 squared minus 7 squared. And then I want to take the square root of both sides. So I get the distance from E to H equals 8.5. F to D. So again, I would draw another triangle. So F to D. So we're talking about this triangle here. So this side is 3. I know the hypotenuse here is 11. And I know that from this segment, so F to D is here. So 11 is my hypotenuse. So these are my 2 legs. So I'm going to set up 3 squared plus F2D squared equals 11 squared. So I'm going to subtract 3 squared from both sides. So I get F2D squared equals 11 squared minus 3 squared. And then I'm going to take the square root of both sides. So I get F2D rounding is going to be 10.6. Okay, and last question, C2D. C2D, so we said F to D is 10.6. So C to F is also 10.6. So this is going to be 10.6 plus 10.6 is 21.2. Okay.